I'm Jordan, and this is Pimp My Ride.
It's going down for real. It's going down for real. Yo, girl, just kiss
To find the acceleration of our car, we must first find the velocity. Acceleration equals change in velocity over change in time. Our ticker tape, here, is hooked up to a 120 volt outlet in the US. Here. When turned on, our outlet, like all outlets in the US, will emit electrons that vibrate 60 times per second, which means that our machine will also vibrate at 60 times per second. For every vibration of electrons, our ticker tape timer, here, will place one dot here on our carbon paper, which will be hooked up to the back of our sweet rides. First, our accelerated motion with our sweet ice cream truck.
That wasn't very good. It's good, it's good, it's good, it's good.
No, it's
It's
not.
good, it's good, it's good. Yes, it is. We can do this part.
No, you can't, because we measured a meter.
We
Restart,
can measure
restart.
on it. We can measure on it.
Redo it.
We
Go
can
throw
measure
that
like 10
out. 'Cause you just
centimeters.
messed it up.
Way to go! First for an accelerated vehicle.
What's that? That was good though.
Now, a car with constant velocity. As you can see with our constant velocity vehicle, the dots stay the same distance apart from each other the whole way down the tape. Whereas with our accelerated vehicle, the dots start off very close together and get further and further apart.
So why is this?
Well, that's a good question, Jordan. This is because our ticker tape timer will put dots on the paper at 60 per second, no matter the speed of the car. When the car speeds up, we'll cover a larger distance with those 60 dots. So as the dots get further away, we can tell that the car is accelerating.
So what's the deal? Why do we care so much about the velocity and acceleration of two toys? Well, here's why. We have a ladder, lights equipped with a block for accuracy, a small steel ball, and once again, our sweet ride. Our goal is to drop the ball from the lights as the car passes under the ladder so that the ball falls perfectly into a cup placed on the top of the car. To do this, we'll need to do some more math. We need to know how much time it takes for the ball to reach the cup mounted on the car. When we know this, we can find the distance that the car needs to be from our landing zone when the ball is dropped. Brace yourselves, it's about to get boring. Using the timeless equation, final velocity squared equals initial velocity squared plus 2 times acceleration times distance, we can find the average velocity of the ball falling from the light. We know that our ball will start at 0 meters per second squared, and because of gravity, its acceleration will be 9.81 meters per second squared. We also know that our ball needs to travel 1.8 meters. So, final velocity squared equals 0 meters per second squared plus 2 times 9.81 times 1.8. After we square root both sides, we find that our final velocity of the ball is 7.41 meters per second squared. To find our average velocity, we need to subtract our initial velocity from our final velocity and divide it by 2. This leaves us with an average velocity of 3.71 meters per second. Now that we know that, we can find how long it will take for the ball to reach the cup using the equation time equals distance over velocity. T equals 2.8 divided by 3.71 meters per second. T equals 0.76 seconds, about the time it takes to blink twice. Stop blinking, this is important. Now all that's left to do is to find where the car needs to be when the ball is dropped, so that 0.76 seconds later, the ball lands in the cup. Well, remember that ticker tape? That handy dandy thing places dots at a rate of 60 dots per second. Since we know that it takes 0.76 seconds for the ball to reach the cup, we just need to multiply 0.76 by 60. The number that we find will be the number of dots that would have been put on the paper in that amount of time. When we do this, we get an answer of 45.3 dots. Now we need to measure the distance of 45.3 dots on our carbon paper. We then mark that distance on the floor so that when the dropper sees the car cross, it will drop the ball, and if everything goes as planned, the ball enters the cup. Now wake up. It's time to drop the ball.
So, yeah, that happened. We did the same thing with our accelerated vehicle, but it didn't work out so well the first time, so it's not as cool. But here it is, like the 4th or 5th time we tried it. That's pretty. Okay, never mind. Maybe that was pretty impressive. I don't have to say now. Good.